Good morning, everyone. I welcome you to the session on visualization for data science. The agenda of this session is that we will try to understand the importance of visualization. We'll start with Tableau and create tables and charts, dashboards, make the data time series and parameter dependent, and also look into some advanced analytical tools. Now, what is data visualization? So data visualization allows us visual access to a huge amount of data in easily digestible visuals. We may have data in terms of big tables, but taking out inferences from looking at the table from a layman, it becomes difficult. And to make a well-informed decisions, these visualization helps us to understand the effect of seasonality and trends and make an informed decision. Well-designed data graphics are usually the simplest and at the same time the most powerful tool for decision making. The scope of visual analytics is it helps us to take better decision making. It gives us a better sense of risk, better customer relationship, better key strategic initiatives, and better financial performance. It can be applied to scientific analytics, knowledge discovery, data management, knowledge representation, presentation, production and dissemination, cognitive perceptual science, interaction, information analytics, geospatial analytics. So for doing the data analysis, what we will be doing or following the steps is we'll be integrating the different data sets. We'll try to analyze them and also produce the visual tables. So why we have chosen Tableau is because it gives us interactive visuals. Quick production time is there. It has got a lot of features. It is flexible and and it's an intuitive platform to give us future trends. So what is a Tableau? Tableau is a software company which produces interactive data visualization products focused on business intelligence. Tableau helps the world's largest organization unleash the power of the most valuable assets, their data and the people, allows the customers to spend more time on data analysis and less on data wrangling. So let's get started. The agenda for the first part of the presentation or the demonstration is we'll be looking at making the simple charts, making the dashboards, and the third part will be dealing with the analytics. So I'll just keep this agenda page and go to the Tableau window. So as we have already shared with you the data set as well as the Tableau link to download, I have already downloaded my Tableau. I'll just open the Tableau. I've kept my data set in the folder. So the location is known to me. So once you all open this, we can continue with adding the file. So I'll just click on, we go to more, desktop, where my folder of, I'll add more. And I'll add the third one also. All these three data sets, we can just open it, the data set and see what is there in the data set so that we will be able to understand how we can join this data set. This is the first data set of COVID-19. Then the second is of vaccination status. And the third is state-wise testing. So if we see all the three data set, it has got all the name of the states in the state column. This has got the name of the states in the state column along with the consolidated India data. And the last is The name of the state is in state and union territory. So this is a field which is common in all the three data which we'll be using for joining. So I'll go back to the sheet where we have opened it. We'll just drag and drop, and it will show that it is not able to find out a common field. So we just need to select it for them. So its state and union territory and now is equivalent to state on this side. So it now identifies and has made the connection. Similarly, I'll add the third. And since it already had the state field, so it could easily combine. So all the three tables are combined. Now we can start with our work. Now we will go back to our PPT and see what all we have seen. Is we started with the Tableau. We have loaded our data. Now first is we want to see the geographical chart of the conform. So let's go back to. So geographical chart means any data which has got geographical information only can be used for geographical chart. And if you see in this, you will see a globe symbol that simply says that it has got the geographical information. So if I want to see the different states and the confirm, I can simply just double click on it. So you see the states are there. I can just drag and drop the confirm to the sizes. So you can see the sizes are showing. Now you will see some 4 unknowns. We can just click it here. We can go to edit location, and since it's not able to recognize, I'll just click on this Himachal Pradesh. I'll just map it to Himachal Pradesh, Karnataka. Again, I'll just Karnataka. Then these two are not assigned, so I'll just say okay, and the remaining two I'll just say filter it. So these nulls are removed, and we can clearly see a big dot in Maharashtra. We can increase the size also to make it more prominent, but this data is to a specific date only, but we know that we have a time series with us. We can add this to the pages column, just drag and drop and just make it exact date. So you will see on the right side a date column being added. Just click on the show history and all, and we can just play it. By just dragging drop, you can just see slowly as the dates are changing. We can clearly see January, there were not many cases, or very slowly the cases you can see are increasing, and how they have become more prominent by the 31st of Jan. Okay, so it's like a time varying data that we have. So the first thing that we could do, geographical chart of the conform. Now this chart can also be represented as a heat map. So first thing is we need to rename our sheet. So I just missed it. I'll remove it so that we don't have any. I'll just name this sheet as confirm in size. Okay. Now let's make a heat map. So again, I take a new sheet. I just double click on this. Now what you see here is definitely it has plotted the things. I want to have the confirmed heat map. Now this time, instead of using the size, I'll be using the color. As I go to the color, you see with the variation in confirmed cases, the colors are changing. darker shows us the larger number of confirmed cases. We can even go to the colors and edit the colors and maybe take some red green diverging with high as red, because presently it is showing low and high as green. So I'll just reverse it so that low is green and high is red, and I'll say apply and OK. So you can see the heat map is created with Maharashtra being the highest number of cases, and each area gets highlighted as a. So this is a heat map of confirmed. Again, I'll rename it. It's a good habit to rename the things, because it helps us to make our final chart. Okay. Now let's go back to our. Now what we want to make is pie chart of the cured people. Again, I'll take another sheet. Now I want to make it for the cured people pie chart. So what I'll do is I'll just put and cured in the columns. Now we see a show me icon on the right side. Just click it here. What all things that you can plot are actually active. Those what you cannot plot are not active. What I want is I want a pie chart. I can clearly see a pie chart here. Just click. You see it's there. Now we just need to make some changes with it so that it's more visible and prominent and gives us more information. Go to this icon, entire view, right? And then we want to know the labels and the count. So what we can do is we'll just take cure to the labels. So it gives us, so right now I only have the number but not the name of the state. Again, I'll take it to the labels. So with the names, I just have the number of people cured along with the size of the pie. So this gives me a good view. Again, this is a data for 1 day. I can make this data as time varying data. So just make it exact date, and we can just do the same things all, and we can just vary and see how this chart is varying. Okay. I would suggest to rename it by code. What we will do is we'll again add to the heat map also. We will add the date in the page so that we get a view of how the data is changing over the time. So exact date. And we can see, we know it started in Kerala. We see 63 unknowns. So first we'll just say edit data. So this is something which we cannot do. So we'll say okay, and let's filter out the data. And so now we have the 3 charts. Let's go back to our presentation. Now what I want is not only pie chart, I also want to have some data in terms of a table. So we'll go back to our, make another sheet. Now I want the depth. So I'll just take states, drag and drop dates, and go to show me. By default, it's giving us the bar chart. We can even take this data as bar chart. You see the arrows. We can just use them to arrange it in the descending order, and we know that Maharashtra is there. We also can add our timeline here so that we can see all the data that is varying with the time, exact date. So just click on show me, show history, all. Just you can see how it is growing. Now this has got a lot of data and some data are not so important for making any decision. We can have some filters also here. So I'll just drag and drop this states to the filter. Now in this presently it has got all. What I'll do is I'll go to the top and I just want to have top 10 as per the number of deaths that are taking place, and I'll say apply and OK. So you can clearly see the whole data is now not there, only the top 10 is there, and this can be useful. So I can just again rename it deaths. Okay. Now we want to see the table also. So table can be there, simple. Now go to the show me and click on this. So it has given you the table. And we can see because of our table combining, there are some repetitions also. So what we will do is first we will add a filter so that our table has got the data of all top 10 states which have got the deaths that is the highest. Okay, so this can also be used. So I'll just write it as table deaths. Now we have enough data that we have created or visualization that we have created with the data that we have. Let's go for one dashboard. So the second symbol that you see with boxes in it, click here, it's a dashboard. Now what we can do is, just because the size you may see as small, it may depend on the screen that size that you have, just make it automatically. So it will make your screen full as per the size of your screen, automatically it will resize. Now we have made all these tables, we'll just drag and drop them and try to arrange it. So now we have all our charts that are placed. We can build our story and everyone has got a name. On the right side, you have all the legends as well as you have your history. You have your time series. So we can just see what happens to this data because all are time varying, all we have set it. So we can just clearly show what are the plot together shows us everything that is changing with the time. So this dashboard can be helpful for us to explain the changes with respect to the sizes and pictures, everything it has helped us. Now, but the point is, some plots are giving us confirmed cases, some are giving us cured data, some is giving us deaths. So if we want to add that all this plot should be like all at a time should be showing us the confirmed information, cured and death, we have an option in it. So let's go back to our sheet. Okay, and now we will do few things. So first thing is just click on this arrow. You see two things, create a field and create a parameter. So what we want to do is we want to add a parameter control. So I just click on this and I say cured, confirmed, and depth. So what type of data it will be, because once I declare it, it will give me all the data. It has to be a string. And then go to the list. In this, we have to take care that we are following the same name. So I just click confirmed, cured, depth. So I've created a parameter. I can just say right click on this and say show parameter. So you can see there is a parameter cured depth, but nothing is happening here. So what we have to do is, after we create a parameter, we have to create a calculated field. So this will be all in one. Okay. So this will be, I'll be using a case statement. Now what we will do is, we will use a case structure. So case will be of parameter. Just drag and drop so that we don't make any mistake. When the first is confirmed, right? Then it has to display confirm. Then when cured, then it has to display cured. I'm just dragging and dropping so that I do not make any mistakes in spellings. When depth, then and then finally end. You can clearly see the equation is valid. You can clearly see the equation is valid. If there are any mistakes, it will be highlighted, and the point of highlight can be clicked to find out the point of highlight can be clicked to find out the mistake. Press OK. Now let's see where is it. It is created in all-in-one has been created. So what we will do is and instead of sum, I'll put all-in-one. So you can clearly see as I make it confirm, the data changes. As I change to cure, the data changes, because now the parameters have been set. Now we need to repeat it for all, and I'll just say here also where I have confirmed in the color, I'll just put all in one. Okay. And also I have to show parameter. Otherwise, I won't be able to change it. Similarly to the pie chart, I have used cured. I'll just remove this cured size and text, and I'll just put all in one for size, all in one for okay. And the next thing is show parameter. So let me check if the data is changing. Last one is depth. Again, in this, what I have to do is remove this, put all in one here. And next thing is show parameter. Coming to the table, again, I'll just remove depth, put all in one into the text and show parameter. Okay, so just let us again see whether the data is changing. Yes, the data is changing. Now let's go back to our dashboard. We can just make this as floating because it's getting merged with everything. And I can just take it and put it to a point where I can clearly see it. If I don't want this colors for the stick, I can just remove it. Now what we have done is we have already added the parameters. What we need to do is now we need to see that parameter. So just click on any chart, go to this arrow and you have parameters. Just click it there. So this parameter is now visible here. So we can just see what is an impact of it. First, I'll just say confirm. And you can see all the charts have changed simultaneously. And if I change this time, all the charts are not only changing, also they are changing with the, say I make it depth. All my charts have changed. If I make it cured, all my charts have changed accordingly. So this is how the same table I could have changed for the parameters that I want to display. But there is a disparity that is quite visible is the naming. We have named as confirmed size, PyCon, Qn and that. So we want to make this also parameter as dynamic. We have an option of doing that. So let's do that first. Now to change the title, we just right click on this and edit, and we want to have the name, whether it is confirmed, cured or deaths. So we can have data and that will be static, and for dynamic you will just go down, you see a parameter cured. I'll just click it here. So it gets added. I'll say apply and OK. So presently cured is selected. You can see I can just edit and give some space for more uniformity. Right. And similarly, I can change this also. Edit title, heat map is fixed. Heat map off. Just insert the parameter. Give some space. Apply and OK. Same with here. Edit title. pie chart of apply and OK. This again, I will just edit. It's bar chart. Apply and OK. And this is table. Table. Apply and OK. Now you will see that not only the data is dynamic, you can see my titles are also getting changed. So this is how we have made our dashboard and made it more dynamic, not only with respect to the time series, the data getting changed as per the death confirmed or cured. Also, the correct naming is being used so that we are able to see the data correctly with the correct name. So we have finished with the first two parts of the presentation. Now coming to the third part of advanced analytics, let's go to the presentation. So I finished with this adding parameter, making the name dynamic. Now coming, we need to see how we can do the forecasting, finding the trend line, clustering, all that. So let's go back to our and make a new sheet. So the first thing is I want to see the trend line. So what I do is I just trend line is with respect to the time. So I take time to the columns and confirmed cases to the rows. I get some plot. I go to the analytics. You see some models that are already inbuilt model. I just click on forecast, drag and drop. So it's taking linear regression. It gives me the forecasted results. This forecast. Now we will go to the forecast, right click and see that what it gives us the forecast options. So it has shown us that exactly presently it is showing next 14 months. I can make it next 1 year, 2 year. So accordingly, the middle line is the median line. The 2R could be the ranges that could be there. And it also shows presently we are taking automatic without seasonality, or we can custom it with say adding some trend line additive or multiplicative and all that. So depending on the data and the amount of information that we have, we can use all these models. So this is the first part that gives us the forecast. So I'll just rename it as forecast. Then we go to, I'm sorry, I have made delete. Now we want to have the trend lines. Again, trend lines we want to see with the dates. Say confirm. Okay, I just make it more elaborate with the months. How is it varying? With the days and exact days also we can add. Now we go to the analytics to see what model. So we have the trend line. You will see there are different linear, exponential, polynomial. So I just select polynomial. So it gives me the trend line along with the model equation as well as the R and the P value, which are talking about whether this is a good result or not. We can see that the R is not near to the 1. So this model is not so appropriate. We can just see whether we can improve it through exponential. No. So I see it for the quarter, and now you can see the results are so model equation is so correct that the R value is 1. So this is what we can directly use the models. So this is trend line. Now, next is clustering. Now, clustering is a technique that helps us to identify the or basically categorize the data. So if I want to cluster the states with a similar number of confirmed cases. So, so that similar strategies could be applied. So first we drop confirm to the columns and rows to the states to the rows. Go to the show me. You can see this first thing is bubbles. So this is one way of doing the clustering, and I'll drop this to the, so this just shows us different states with the data of confirm. But this is actually not giving grouping them, but individual data. So this is, I will name it as bubble plots. Now let's see how clustering can be applied so that this data becomes more meaningful. We'll go to the advanced and do the clustering, and now again we will apply. So it is asking us how many clusters do we want to have, 4, 5. So I just say 5. Automatically it had done 3. So now you can see the Maharashtra is so big that no other state is matching to it. And this is the clusters giving us that it has divided it into 1, 2, 3, 4, and 5 colors. And their data of the similar colors are near about the same. So that will help us to strategize and make the things. So I'll just rename it cluster. Now, in addition to this, we saw sometimes we are not able to see the forecast. That could be because of the missing data. So we can ourselves use some inbuilt model equations. So let's again go back to the date and say confirmed. Say month-wise, this data is there. Now I'll just create one field. Go to create field. I'll say it as model 1. Now this Tableau gives us some inbuilt models for predicting the values. So I just type model. So there are 2 models that we can use, this percentile or quantile. So as when I'm clicking on the one, you can see returns a target numeric value within the probable range defined by the target expression and other predicators, and this gives you from the probability depending on the probability. So we can just pick quantile. We'll be taking the mean value, so I'll be just putting 0.5. Then we can have different models that it offers us, Gaussian and other. Presently by default it will be taking linear. We are sticking to that. Then the target equation is what I want to predict, and the second is with respect to time. Now in this, there are a few things that we have to do is aggregate value. We have to give up the date. So ATTR is the function, and with this we have to again truncate the date. So this is a syntax that we'll be using. And just as we can see some reds, now that equation is valid. So this is the equation that we are using. We'll just modify it with the type of model in the second case. So you see the model is created. I just drag and drop it here. So there are 2 things that are available. I just go here, right click, dual axis so that we have a comparison, and I also do synchronization so that this model equation, go to the analysis, info properties of the missing parameters. Now we'll make certain changes before we could extend the axis. I'll just make it exact date. So now we have the data as per the date, and now we want to extend the axis. For that, we have already ticked on info properties from missing values, and we'll go to the date. Now you will see below show missing values, there is extension of axis. We can extend it by say 1 month, 3 months, 6 months. So we can see the data is getting extended by 6 months and giving us certain information. So this is how another way of forecasting. We can see initially the forecast was missing, but we could use some model equation. Now we can, as I told you, we can further enhance this model. Just right click, go to the edit. In this, we can add, we can add here one model equation in single quotes, type model equal to, if I like linear, it's by default, it has already taken linear, comma, there are some errors. I just, so model, it's in double quotes. So there's one more error. Now it's a valid equation. Now we can say apply. So we see no change because it's by default linear. I'll now again edit it and make it Gaussian. For that, the keyword is GP. I say apply. See how it has changed. And we all of us are knowing that the trends have started reducing, and it's a more better model that you can see. There is a third model also, regularized linear, that is RL. So we see that it's similar to linear, and the best one we could see, which is actually, since the data is still 21 September and we know the trends are downward, the Gaussian is the best one to give us the result. So this is how we could resolve the problem where forecast is not available using the machine learning prediction models. So I'll just rename it as model and keep it at Gaussian. Okay. Now, coming to one more feature that helps us in data science and statistical analysis is, suppose I want to know confirmed state-wise, and I want to have a whisker model. Yeah. Now let's try to make the whisker model of confirmed. So what do we see is the mean upper whisker, upper hinge, and all that data is there. And in this, it's skewed to negatively skewed, as well as we see that there are some outliers, that is Andhra Pradesh, Tamil Nadu, Kerala, Karnataka, and Maharashtra, which are beyond this limit that of average, that which are the outliers. So we just name it as so we can make another dashboard with all this new charts that we have. As I told you, we'll make it automatic. and just have some again adjust and then it is like a analytics we are able to reduce. Thank you all.